Okay, so hi everybody, I'm Roger and this is Jake, and we're going to try to give you a sense of all the different pieces of the Tor community and ecosystem. Lately we have something like 5 or 10 or 15 full-time developers, and we have another 50 or 100 part-time volunteer developers, and then we have several thousands of people outside of that. There are a lot of projects that we've started and that we cannot maintain by ourselves. So a lot of the things we're going to tell you about today are projects that are partly done or unmaintained or have a lot of bugs, and we need your help to try to make them good. So we're going to try to give you a sense of all the stuff that you can help with. If anything catches your eye, we'd love to chat with you more afterwards. I have a little note here. We have 3 tables on the first floor next to Heaven after this for the next couple of hours. So there's plenty more to talk about once we're done here. Okay, so the very first step. The Tor software, once upon a time, Tor was just a SOX proxy. It was a program. If you configure your applications to go through the SOX proxy, you're good to go. And that was it. We gave you a proxy, and good luck to you. And that Tor client, it was a client, it was a relay, it was a bridge, it was a directory authority, it was all of that in one. But there's a lot of other applications that we need with it. For example, Tor Hidden Services. So a lot of you have probably heard of Tor Hidden Services. They let you run a web server or other service in a way that nobody can locate where on the internet it is. There are 2 big problems with hidden services. One of them is they're slower than they should be. There's a lot of extra latency involved in the rendezvous connection. And the other one is they're less secure than they should be. Basically, hidden services stay at the same location, and the adversary can induce them to talk. And because of these 2 properties, it's much more straightforward to trace the location of a hidden service than it is to trace the location of a Tor client using Tor for normal forward anonymity. So there's a lot of performance measurement and improvement, and also anonymity research and design that we need help with there.
We should mention this star and keyboard up there. Some of you may be familiar with this logo. Whenever you see that, that's something where we really, really want help with it. And it is often the case that for the things we really want help with, there is funding. So if you want to quit your job writing police malware, especially, if you don't want to kill yourself and you want to go on to do something useful, these are things we could really use help with.
Yep, so we picked this one out in particular because there are a lot of developers who are focusing on other things, and hidden services are basically falling by the wayside. So there are a lot of people who care about them, but nobody really works on making them faster or more robust or safer. So we'd love to have some help there.
And so this URL is something that's worth, I don't know, if you want to pass it around. This is the way that we hire into the Tor project as well, in general, and the way that everybody that works on Tor has really become a part of it is they come to our website, or they come to an IRC channel, or they hang out with us at the Congress, and they say, here's what I'm working on, here's what I'm really interested in. When you need to do a thing, think of me doing these things. And we helpfully put on this page information about who in the Tor community, now that it has grown so large, is the right person for a particular project. And the best way to find them is on our IRC channel, which is also listed on this page, or from this page you can find it. And hopefully that single URL is enough to get involved. And if you want to talk to us or verify PGP fingerprints or OTR keys or whatever, we're here as well for the next several days. So if you want that URL, there it is.
Okay, so the main way that we recommend using Tor is the Tor browser bundle. It's a suite of applications, including a modified Firefox and Vidalia and Tor and so on. And the goal is that it's a self-contained approach that you can stick on a USB key and take around, and it has everything that you need inside it, so you don't have to install stuff and smear it around your hard drive. So there are 2 pieces to this. The first one is we need build scripts, build automation, QA, all the stuff that you would want from take these pile of sources, turn them into a binary blob that you can give people that they can unzip and use on Windows and OS X and so on. So there's a lot of sysadmin-y automation work that we'd love to have some help with. The other side of this, Tor browser is actually a Firefox fork. We have a bunch of privacy and security patches on Firefox that, for various reasons, they haven't been willing to merge into Firefox yet. So we ship a separate browser that tries to take care of a lot of the privacy application level issues. One day we would like to use Chrome rather than Firefox because it has some really nice isolation properties. But right now, there are a bunch of really critical privacy bugs with using Chrome for Tor. For example, if you're using it on Windows, you fetch the SSL certificate. Chrome says, hey, Windows, what do you think about this SSL certificate? And then Windows goes off to the MS Crypto API, which doesn't know what a proxy is. And it just goes out and checks revocations and so on without knowing that Tor exists. So these are some big issues that make Chrome impossible to use with Tor yet. We'd love to have some help with that.
I mean, you can hack it, obviously, but it's not at the point of being usable. It's not at the point where we would recommend it for leaking documents or something like that. It's totally possible to get there, and we have a roadmap, in fact, to get there. And ultimately, it would be nice if every browser could be used seamlessly with Tor, where when it said private browsing mode, it meant that it was actually private, as opposed to, well, we're not actually going to give you private browsing at all. Or anything even remotely close to it. So this is sort of, if you care about private browsing, if you care about just being able to bypass censorship, Tor browser is the way to go right now, we think. We'd like it if every browser could just merge with this at some point, because this is a set of features, almost a specification. And we don't really actually want to be the only people that are maintaining such a piece of software. In fact, we don't want to do that. That sucks. We want to do something where everybody normalizes towards privacy, as opposed to everyone normalizing towards spyware.
OK, so once upon a time, we had a Firefox extension called Tor button. I imagine a lot of you are familiar with you used to install it on your Firefox, and you could toggle use Tor or not use Tor. That was the old approach, back when we imagined we could keep you safe in the toggle model. The problem is that there are so many different cookie or cookie-like things that websites can make your browser keep, so that when you start using Tor, then it can recognize what you had done back when you weren't using Tor. So the new Tor button is an actual Tor controller. It can talk to Tor in various ways. It's got a little set of options up there. We would like to make it to the point that Tor button is the master control of Tor, and we don't have to deal with Vidalia or other GUIs, which we'll tell you about in a bit.
Yeah, so the one thing that's worth mentioning about this is there are some fascinating isolation properties that we need to solve that are actually, it's probably a security paper, but it's essentially the case when you have a Tor controller, it can control Tor, which sounds very obvious, except that if you can control Tor, you can't, at the moment, merely control it just to do certain things, like give you a new identity. For example, you could also control it to use different directory authorities or build custom circuits. So it means that a website that can own Firefox, anybody know about those? So if you had one of those, it might be able to do some nasty stuff. So we're trying to make it more usable, but there are real security trade-offs there, and we want to make the best security trade-offs for users. So if you are interested in Firefox hacking and you have some ideas about how to keep these isolated, or if you have ideas about how to change Tor so that we can have certain things configurable but not everything, and you know what that balance is, we'd love to talk with you about that.
And we do have a feature in Tor recently where you can isolate different circuits depending on what applications are talking to it. So for example, if you make a socks handshake and you provide a certain username, and then you make another socks handshake with a different username, then Tor will keep all of those streams separated inside Tor, rather than mushing them onto the same circuit and potentially combining your profiles.
Now, one thing that's probably worth mentioning is we would love for people to understand that it is actually fine to log into services over Tor. There's a question that people often ask is like, well, do you think it's all right to log into Facebook with Tor or something? And well, I think personally you probably shouldn't be using StasiBook. It is the case that people do it, right? And if you're going to do it, there is the question of why you would want to bear back with the internet. When you bear back with the internet, you bear back with Big Brother. So probably it's worth considering that you want to use Tor and Tor browser for logging into things, but you also want to keep in mind there are these different adversaries. So the Tor browser tries to make it such that when you are browsing the web, it is the safest possible experience. And if you also happen to work with App Store models, or you want to help to make these things all work seamlessly on a different platform, it would be interesting to try to get Tor browser into the Apple App Store, for example, which also I don't think you should be using it. But if you're going to go with the walled garden feudalistic approach to software management, maybe you should be able to have some privacy.
So that might be the future of Tor controllers, where Tor button actually launches Tor and it takes care of everything and has the interface for configuring things. The present is Vidalia. It's a Qt-based C++ application. And the idea is you've got various things you can click. I'm sorry for the resolution. It actually looks slicker on your computer than it does up here. But you can view the network. You can start and stop Tor. You can set up relaying. You can switch circuits. You can get a cool bandwidth graph. You can get a map of the relays and see little lines between them. And it's got a lot of useful stuff, but we don't really have a maintainer for it right now. And there are a bunch of features that a lot of people would like it to have. So there are bug requests and patches queuing up and nobody to look at them. So we would love to have some Qt hackers who want to help make this thing be the GUI for Tor.
Does anyone here hack on Qt or C++? Raise your hand. You.
One hand, two hands.
2 hands.
3 hands.
Come talk to us afterwards.
Okay.
You're a rare breed. This is a pretty awesome little controller. It's basically a console ncurses controller that is written in Python, and it's really nice because you basically can just start it up and start talking to Tor, and you don't need to have X windows running. So it's really nice for putting it on a Raspberry Pi, for example, or on another device. It's very lightweight. And in fact, I was walking in the Hack Center last night, and I saw that there was some people from Le Quadrature de Net, and they had a projector running ARM, showing that they were running a very fast Tor relay on a Raspberry Pi, which is really neat.
So if you're going to be using Tor as a client, the Tor browser bundle with Vidalia is the right answer. If you're running Tor as a relay, then this curses-based, console-based thing is way simpler, and you don't have to deal with X and all of that.
You can toss it into screen and just leave it there and then reattach later and just see what's going on. You don't have to expose a web server or have extra windows running or something. And it's pretty straightforward, and it seems quite obvious, and the author really puts a lot of effort into it, so we're thankful that it exists now. This is kind of a sad story, which is Qt developers are hard to find, but apparently there were enough of them to make 2 Tor controllers in Qt. And this one is, it's not so much dead as it is. No one is maintaining it. I think it actually still works, but it doesn't do all the things that we need it to do. So if this was more interesting than Vidalia is, you could actually adopt this as well. I don't know anybody that is using it, but it's great. Just because someone put the effort in, and they put a lot of effort into it, I might add. The same author also wrote a fork of a web browser that was totally Torified, and it's very slick. And so he has a really good vision, but he also has a day job and abandoned it.
Okay, and there are a bunch of other controller libraries that these tools use underneath. So Stem and PyTor Control are Python-based libraries that you can use in your application to be able to talk to Tor. You can say, please let me know how much bandwidth you're using. Please build circuits like this instead. Please set up a hidden service. Please reconfigure your Tor. And then TX TorCon is a Twisted-based one where they actually have a pretty good interface for setting up a hidden service, and you're already using Twisted, so you might as well have a web browser running inside also. So there are a lot of different ways that you can do that inside Twisted so that you don't have to keep adding other applications that probably have security problems and need updates and so on. So the old model of a hidden service is start up your Apache and hope you configure it to lock it down. The new model of a hidden service should be spin up a web server inside Twisted.
Yep. And we also, I think, for most of the stuff we're doing, we try to make sure that our community is really tied into lots of other communities. And so we work very closely with the Electronic Frontier Foundation. And they have been working on this HTTPS Everywhere plugin, which some of you are probably familiar with. Anybody here use it at all? Yeah, not bad. Cool. Right on. So the Firefox version is, of course, in Tor browser. And one thing that I was thinking about earlier when we were discussing this talk was that it might be useful to have a way to have a continuous integration of websites that support SSL, that do so correctly. And when you have it and you are using it and you think it will work in the future, someone gets a notification when that ceases to be the case. Because when you try to do things securely and it fails, it doesn't fail very gracefully in modern web browsers. So if this is interesting to you, this is something which is very useful to a lot of people, and it's helping us to transition from an internet where there isn't a lot of security to one where there is still not a lot of security, but at least the hope of some security in the case of SSL.
So we co-maintain HTTPS Everywhere with the EFF developers as a core piece of the Tor browser bundle. We also include NoScript, A lot of people get confused by the configuration, though, because we ship NoScript in the Tor browser bundle with JavaScript completely whitelisting everything. So it will run JavaScript from anywhere. And we get a lot of bug reports from people saying, you've screwed up, you shipped JavaScript, but you made it weak by default. And in fact, we use NoScript for the fact that it makes it harder to launch plugins when we don't want to use them, and it deals with various third-party injection stuff that maybe Firefox should be solving by itself, but that's why we include NoScript.
So how many people here have ever installed Windows and then installed another piece of proprietary software garbage on top of it? All right, so that's everybody, probably, even if you don't want to admit it. So the thing, and not me, but the thing is that we don't have to live in that world anymore for a bunch of reasons. But if we were to just limit it to that software and what it does to your computer, it is the case that update systems or installing, which I've had a pretty incredible debate with some Firefox people about this, installing is part of the update process. It's the sort of first leap of faith problem. And we have been working on trying to solve it. And there's a really wonderful researcher by the name of Justin Kapos who worked with a bunch of people at Tor and basically started working on some papers and came up with a thing called TUF, which is the update framework. I'm sure I'm getting the chronology of that slightly wrong, but basically the deal is that it is an updater and an installer and a package manager that can work with other package managers on a system that can defend against man-in-the-middle attacks that feed you an infinite byte stream so you never get a complete file to do a hash check, like all kinds of things for denying updates.
It can deal with freeze attacks where it doesn't tell you there's an update even though it is. It can deal with rollback attacks where it tries to tell you the time is wrong so you don't bother to check the new ones.
It can deal with things like your key has been stolen for signing and you want to still be able to update people and let them know that the keys have been stolen, and you can do offline signing and all kinds of stuff so you can air gap your update system. Things that make it possible for you to actually use the internet when it is hostile. The internet is pretty hostile. We have an anonymity network where we want to make sure people can update it. People try all the time to block systems that use Tor from updating or from being able to reach our website. So if you're thinking about writing software where people install or update it, this is something we could use a lot of help with. And we, I think, basically have a prototype implementation that should work.
We have a research paper, we have a design document, we have a prototype in Python. It works if you know how to use it. One of the challenges left is how do we integrate it with the Tor browser bundle so that the right stuff gets run at the right time and there's an interface that tells the user something and we actually offer the updates when we should be offering them. Or maybe we should throw away the Python version and switch to something like C so it's more portable.
Or if you fancy Golang, I think that's a pretty interesting language, and why not decide to reinvent the wheel all over again in a new language? So this is very great. Also, just looking at the paper, you can see everybody gets installers and updaters wrong pretty much by the way the paper is written. And so if we all work together on this, it really benefits everyone, but it especially is something we need so that we can keep things going. For example, the BitTorrent aspect of this is such that there may be a time in the future where you'll be able to find out that there is an update and then learn it from many, many people, or you can download the update itself from many, many people. And this is nice, especially with BitTorrent that uses the unauthenticated Diffie-Hellman for dealing with traffic analysis. So that kind of stuff actually makes it significantly harder for people to block and to censor. And if a lot of applications are using this, it is especially the case that blocking and censoring it becomes hard because it will not just impact Tor or Tor browser, but rather everything. So hopefully this can solve an entire class of problems that we face. Anybody interested in helping with that? Raise your hand. No stress, but you. Come talk to us afterwards. This is a small shim. It's basically, it's a library written in C, and we're about to do another release of it pretty soon. It has a command called use with Tor. You can say use with Tor space SSH, for example, and then SSH to a host, and it tries to overload with LD preload or similar functions on different operating systems. And basically, it makes it easier to use things with Tor. It is a way to have a Tor configured in a text file and basically overload socket calls so that you talk to the Tor that is configured, which is kind of nice. So you don't have to write into every application some kind of SOX proxy handler. The problem with this, of course, is that that only handles the getting your bits into the anonymity network part. It does not help with the part where you may send bits into the anonymity network you do not want to send. So it's part of the puzzle. It's not a whole solution, but it is extremely useful. Pigeon is an old-growth forest of 0-day, but it is also an extremely useful program that lots of people use. And while they seem to refuse to ever put out a Windows update for all of the bugs that I have found, including like 12 remotely exploitable problems, you should read their bug tracker, by the way. They need a lot of help too. They were very nice and added this, which basically says, we are aware that you do not want to make DNS requests outside of your proxy. It's like really great that they did that. They didn't go all the way in that it still requires some configuration, but they have actually put some effort into this. And they're almost a model of how to integrate Tor into a program. They're still missing a few pieces, like the fact that if you're using it, you may probably already be owned. But other than that, they're doing a good job. That's all me right now. All right.
Okay, so once upon a time, we actually shipped with Privoxy or Polypo, which were HTTP proxies. And the idea, at the very beginning, Firefox could not handle SOX proxies well. It had various bugs where you try to use the SOX proxy and it had a 10-second hard-coded timeout that can't be reconfigured and stuff like that. So we shipped an HTTP proxy so that it would be Firefox to HTTP proxy to the Tor or SOX client. And then Firefox fixed itself enough so we no longer have to do that. It's still useful in some cases when you're using an application that doesn't have good SOX support to be able to go through something like Privoxy. We used to recommend Polypo for a while because it was faster, it was smaller, it could do HTTP 1.1, it could handle the keep alive and pipelining and so on. But at this point, Privoxy is probably the better bet, even though it's a little bit larger and clunkier, it's probably safer to use. And we also have shim, which...
Yeah, so shim is basically exactly what it sounds like, right? It sits between whatever application that needs an HTTP proxy and Tor as a SOX proxy, and it tries to stay out of the way. It tries to be fast. It tries to use, well, it does use libevent too. So it's actually really nice because it's designed to just do the simplest possible thing, which is translate between HTTP and SOX.
But it has no maintainer.
Well, sort of. So I've been maintaining it a little bit, and it compiles again, which is good. But it's not really ready. It's not really ready for use. It needs to be packaged for Debian and other operating systems, and it needs to have some people audit it. I think there's a great internal debate inside of Tor as a project in general about whether or not we should support HTTP proxies. And I mean, it sucks, but I think the reality is that application designers and implementers use HTTP proxies, and that is just the way that it goes. And so even if you're using a SOX proxy, there are cases where you will still leak DNS. For example, I think it's GNU PG for the TorBirdie program, which we'll mention in a moment. There are these 5 different cases, or there are n different cases where if you're using the SOX proxy, it will or will not leak DNS. If you have these other configuration flags, it may or may not leak them. But if you use HTTP proxies, the way that it's set up, it won't leak DNS, usually. And so as you can tell, it's sort of complicated, but it is, I think, still important to actually have it. So we really need help with this because it's very small, it's lightweight. It means that when we bundle it with another program like Orbot, we don't have to ship Privoxy. I mean, if you look through the source code of these programs, we audited Polypo, for example, at a Congress, I think 2 years ago when we decided to drop support for it, and it was just, like eyes bleeding terror. And, shim is not like that. But still, we need help with that. We probably need the little keyboard star up there, but TorBirdie is an experiment right now. I mean, I use it every day. Who here uses Thunderbird? Anyone? Okay, so this is for you.
Well.
Yeah, I know, right? That's we're working on it. So I also use Thunderbird, and I thought, gosh, it would be really nice for the times in which I use Thunderbird if I could just use it with Tor. And gosh, did you notice that for some reason Mozilla ships with a whole bunch of SSL stuff that should be disabled, and they do a bunch of stuff where this is not as secure as it could be? So what we decided was we would make it so that if you install a single plugin and you have Tor running, or if you have John Doe's running, actually, we were working with them a little bit on it, you would be able to, with just one install, and you have to tell it what kind of proxy you want to use, it will just work. It will remove headers, it will disable HTML mail, it will even add some privacy-preserving options to using Enigmail if you happen to use it, and it just works if you have Tor running. There is a problem where if you don't have Tor running and you don't know what Tor is and you install it, it will just not work and you can't check your mail, which is nice that it feels closed, but it's not nice that you can't check your mail. So we could use some help with this. There are 2 patches in the Mozilla Bug Tracker right now, which we've been trying to shepherd through now for, I don't know, 6 or 8 months or something, and for some reason there's a lot of foot dragging. So if you happen to work in the Firefox community or the Thunderbird community, and you know how to review patches, we could really use some help just on reviewing the code we've already written to make this so that it's just a single plugin without having to build it from scratch. Because we had to fork Firefox to make it privacy enhancing. We don't want to do that for Thunderbird. We want every Thunderbird user out of the box to install a single plugin and just be good to go. Or a single extension, I should say. And so if you want to try it, it's an experiment. There are a couple hundred people that use it every day, which is, it's kind of nice. So TTDNSD is sort of the same thing as shim, but for DNS. In the future, this will probably be dead code. It is already sort of, because there's been a bug open that I just don't have time to fix. We are looking into replacing it with something like Unbound, and libunbound might be kind of useful. Paul Waters has been helping us a little bit with that. And so there are some prototypes to make it so that you can run an Unbound cache with DNSSEC and everything, and then shim that over Tor, essentially. And then you'll be able to do full DNS over Tor. The Unbound stuff does work now, but it is not as straightforward as simply installing TTDNSD. Orbot is really awesome. Who has an Android phone in here? OK, so who here has Orbot installed already? OK, for the rest of you, you should install it. If you want to, obviously. Because what this basically gives you is the ability to use Tor on your Android device. So I have this Nikon Coolpix camera here, for example, and I just went to Burma, and I thought, gosh, you know what I need? I need some way to get onto the internet that is not completely obvious that it is an Android device. When someone breaks into my hotel room or something and they backdoor my computer, they probably won't think to backdoor my Nikon camera, and I hope. And it's nice, it has GPS and other stuff, and it can browse the web anonymously, because Orbot just works on almost every Android platform. So it'll start a C version of Tor, the main C implementation.
It's not a port, it's the Tor client running on Android.
Yeah, and it'll have also on it right now, it's got a proxy as well. And so you'll have an HTTP proxy. And it's pretty useful to be able to use it, basically. You can be a relay, a hidden service. So if you have an Android phone, you can get like a connect back shell everywhere you go with it as a hidden service, which is pretty useful. There's also OrWeb, which connects to it, so you can browse the web anonymously. It's pretty great. It could use a little bit of help in a couple of ways. Like, for example, we could use some help knowing on what platforms it's not working. We kind of related have another project called JTor, which is the Java Tor implementation, a totally different version of Tor. And it would be nice to replace the C Tor on this with JTor so that it just works everywhere, or we debug it everywhere. I forget what the Java slogan is. But Gibberbot is an example of how to connect these things together. And basically, Gibberbot can, with a single checkbox, go over Tor. So for example, anybody in here use jabberccc.de? OK, right? So if you type in, I'm root at jabberccc.de, and you type in your password, it will connect to the Tor hidden service version of the Jabber server, just straight up, if you tell it to use Tor. So it's one checkbox, which is significantly better. And the application was written with this in mind, which is, I think, quite nice. This camera is not working.
So this is for instant messaging and OTR, but there are a lot of other features that we could add into things like Gibberbot. For example, a lot of people already have their phones. They're already set up to do chat. Wouldn't it be nice to have some sort of not quite real-time voice, but some sort of push-to-talk where you record, you say some stuff, it turns into an MP3 that goes over the Tor network. The MP3 gets played by the other person's device, and now you're having almost real-time voice communication over Tor in a way that is just like any other TCP connection.
And a really nice thing about Gibberbot as well is that it supports OTR in Java as well. So I think you're in better shape using Gibberbot than Pigeon, for example, even if you had to run an Android emulator. And this is pretty straightforward. So I would really recommend using this if you're using Android and you wanted to chat. And if it doesn't do exactly what you want, the help we could use on this is telling us how it could behave better, or it could be smoother or something. And that would be really, really nice. And we'd also like to improve it to make for more interesting ways of verifying OTR keys. I mean, you have a physical device. You have maybe a barcode scanner in the form of a camera. You have a screen. Maybe you have some like near field communication. You should be able to, in theory, be able to verify keys with a whole bunch of people in the same room automatically. There are some good research papers on that. Someone that wants to work on that, we would love your help with that. So this is not really ready for prime time, and the help that I would ask for with this is a little strange. But there's a fellow by the name of Adam Langley, who is one of the greatest living cypherpunks, in my opinion, just an amazing guy all around. And he decided that traffic analysis is a pretty big problem, and he decided the anonymity problem's been solved as much as is possible. Let's build a not quite email, not quite instant messaging, forward secure way to communicate with people where you don't have metadata left around, where the servers only have very minimal amount of information that allow someone to know if they're allowed to post certain messages or not. So it uses group signatures to deal with spam. It uses Diffie-Hellman in the beginning. If you see this here, it says begin pawn key exchange. I wrote, I'm adding Alice as my contact. I give Alice this key exchange message over, say, an OTR verified connection or a PGP signed message or something. Alice responds and gives me a handshake. Now I have the ability to compose a message, which is a lot like an email. It breaks it down into 32 kilobyte chunks of data that are encrypted. And there's all kinds of cool stuff we're hoping to do with this. It is not right now free software because we don't actually want people to use it. Because we don't want someone to look at it and say, oh, this is the best thing in the world, I'm going to rely on it. But the source code is available. It's actually also written in Go, which is, as I was saying earlier, totally an incredible programming language. And so if you were interested in this, we could use some help looking at the threat models and, well, the source code, the ideas we have. And we're also working on an aspect of it called Panda, which is a protocol where if you want to meet a person, you can exchange a shared secret. And I haven't really talked about it in public, and it's also not really ready for prime time. But the idea is that you give someone a shared secret, and you can meet them again, even though you don't have a common identifier. So I have some other nicknames for this protocol, but we're calling it Panda right now. And this is something where we could really use your help because it is a messaging system that will work over Tor and Tor hidden services that will allow many people to communicate and to have randomized, seemingly randomized traffic protocols, rather seemingly randomized traffic profiles, which is very useful, I think. And it is something much better than email in a lot of ways, but it's obviously a little strange. For example, the outbox and the inbox automatically erase messages over time, so you don't have this problem of keeping around old messages. I think that's a problem, because if I wanted to reply, I should have done it already, probably if it's like, say, 3 weeks old. And if I haven't, it's just a burden. So detach from attachments and use Pond.
Okay, so those were a bunch of applications and ways of using Tor for various application approaches. Now we're going to switch a little bit more to OS images and things like that. Tails is a live CD based on Debian that has all the applications that you should want to use with Tor and Tor pre-configured. So you stick it on your USB key, you walk into the internet cafe or whatever, you boot your Debian-based live CD, you use it, and then you turn it off and you walk away, and it's got all sorts of anti-forensic stuff built in. Part of our goal is, since it's by Debian people using Debian, a lot of the stuff that it's working on should work its way back into mainstream Debian at some point. Another thing that we really need some help on, right now it works well. You boot your Debian, you've got Tor, and you've got your Firefox, and you can use them in the same OS. It would be really useful to have sort of a twin VM model where you can start your Firefox in a VM, and then outside of that is your IP tables rules and your Tor client and your network manager and so on. So that the Firefox, even if somebody 0 days your Firefox and breaks in and is able to take control of the system, they still can't learn what your IP address is. They still can't make a non-Torified connection out. So the goal would be to isolate various pieces of it in different VMs. And we're getting, in the world of cubes and so on, to the point where that should not be too hard to do. And it should improve the security a lot without, I hope, screwing up the usability too much.
I mean, obviously, there are caveats to that. Like, virtual machines are not really great for security. Obviously, it goes without saying. But there are certain kinds of just accidental configuration issues that can happen that model would help with, and we're not dealing with the fact that virtual machine breakout bugs exist in that model.
But they're less common than Firefox breakout bugs.
Exactly. So there's a trade-off to be made there, and we would love to talk with people that want to help integrate that into Tails, because Tails has the right model for sustainability. That is, putting things back in the Debian GNU Linux universal operating system, which many people use, and it is the basis of many other operating systems. So if you're interested in this, or if you're a Debian package developer, could you raise your hand, maybe? Any Debian people here? You're all gun shy. I know there are Debian people here.
There's one in the back.
One, just one. Lights come on. Great. Yeah, so if you'd like to help us, no pressure, but I know what you look like.
Yeah. One of the other really valuable things about Tails in general is their approach to documentation and describing their design. They have a long document that describes these are the security goals we have in mind and these are why we achieve them. So just as Tor Browser Bundle has a big list of here are the different things we want to get out of our Firefox, Tails also has a big list of this is what we hope to achieve and this is why we achieve it. So there are various groups who've been trying VM-based approaches, but they never produce more than a binary blob of some sort. So what we really want is somebody who's able to think methodically, what's the threat model, what are the goals here, what can we get, which parts of these are free software so that we can do the licenses correctly, how can we automate the building of this and some sort of QA around it.
So TLS Date is an experiment that I started, and somehow it actually came to exist and is used. And as I understand it, it's now the default NTP client for Chrome OS, which is a weird, totally weird way for this thing to have gone, because the idea is that it uses, in the TLS handshake, I think it's the first 32 bits of the client random and server random field that are cryptographically protected. That's the system time. Number of seconds since 1970. So the idea here is if you can make a TLS connection, you can set the time on your computer, which that's actually really useful, it turns out, because without secure time, you can't really do much of anything, especially if someone wants to try to replay, let's say, what time it was some time ago and then give you an old version of the Tor consensus. So we wanted to have a secure network time replacement. It is not a very good NTP replacement, but it is a great way to make sure you have a cryptographic leap of assurance as opposed to, I ran Paul Vixie's NTP on this network here. Oh my God. And that was very important. So if you are interested in auditing it, we could really use some help. Or if you want to help make it as actually accurate as Paul Vixie's code, which is very good for that, it is privilege separated, it is written in C, and we are also looking for people to help us write kernel hardening related stuff like SE Linux and also libseccomp, if that is interesting to you.
Okay, so another approach on the OS image side, we have cloud images for Amazon and various others where you run a bridge in the cloud. The first approach for that was let's have more ways for people to volunteer to run bridges, but I think there are a bunch more different models we can use here. One of them is I'm in China, I'm censored, but I can get to Amazon and I can give them $4 US or even maybe free, and I can spin up a bridge just for myself that only I know about, and then I can go through Amazon to bridge into the rest of the world. So one of the nice things here would be to provide automated, maintained images where anybody who can get Amazon to run an OS for them, an image for them, could basically spin up their own private personal bridge that they don't have to tell anybody else about. Okay, and then there's Tor RAM disk. Wouldn't it be nice if you could run your Tor relay without ever having a disk attached to the system? So you pop in your Tor RAM disk, you boot it, it has a Tor relay in it. It either reads the Tor relay's identity key from some other file, or it just generates it every time you boot. And it runs the relay in RAM until you lose power, and then you do this again the next time you start the system. So at this point, when somebody comes in to pick up your computer and walk away, there really is nothing on the hard drive, if it even has a hard drive.
It would be nice to make this work on lots of little embedded ARM systems, such that if you can boot the system is now just a Tor relay. And it would be nice to add some things, I'm sure, to that, like a nice little graphical interface or something, or like ARM to run immediately. And instead of having to do anything at all, you could just turn it on. That would be a very, very fun project. Like if somehow we could get this to run on one of those RIPE probes that they are handing out here, that would be neat. I don't know if that's even possible, but this is something which is totally maintained by the community, and it's a really great thing. Lots of love to them. This is another sort of strange thing maintained by the community. People here are probably familiar with Jaromil, the totally incredible Italian guy. Just really great talk at the camp about capitalism, for example. Anybody here know? Dynabolic, his live CD or anything like that? he decided that he wanted to be able to have his television devices run Tor, and so he ported it over, and like you can install Tor on the TV. There are a whole bunch of things like the AnyTV device by Bunny Huang. This would be a great target for expanding this idea of Tor TV. Things that plug into televisions that are getting power, that are on the internet. Why aren't they Tor bridges? Why aren't they Tor relays? If they're going to be on all the way anyway, you could probably, even with the AnyTV, write a plugin that says, you're watching something on television and it says, hey, you just helped the censored user to connect to the internet. Thanks. And then it could vanish again from your screen. Right? So, I mean, these things are totally possible now, and Yaramil was one of the first to work on it, and it exists. The Tor router project is something which has been being developed, I guess, we've been developing it on and off for quite some time. Part of the reason I was working on TLS State was for Tor router. We needed a way to have a home router get secure time, so that's how we came with that. There are a whole bunch of other things we're probably going to do, like re-implementing DHCP clients in type-safe languages. If you're interested in just OS level stuff, this is a project where we hope to be able to have a piece of hardware, of open source hardware, and free software driven that you plug in, and instead of plug and play, you just plug it in and it works.
And we need the broader community working on this sort of thing, because Tor developers have lots of things they should work on, and re-implementing DHCP clients is probably not on the top 100 of those things.
Yeah, you can hear what he's trying to say to me there as the subtext, huh? So, if you are interested in this, we could really use your help on it. And in particular, we are using Debian, and some people really like OpenWRT as well. We would hope that whatever device we choose, you'll be able to decide to reflash it. But one of the things we want is to make sure that the Freedom Box, the Tor router, whatever devices like that exist, that we share a common ecosystem of software, that it is privacy preserving, that it works automatically, that it provides things that are useful, that it also does other things other than anonymity. For example, if it is possible to use it to replace other proprietary devices in your house that you were going to pay for, why not put some of that capital towards doing a bunch of other things that you care about and the thing you really wanted out of your device? So if that's interesting to you, definitely come talk with us. And if there are particular things you really want us to avoid or things we should really think about when we use Debian as a base, we would really love to know.
Okay, so there are a bunch of other libraries that we depend on, and as usual, the more we depend on them, the more we start to maintain them ourselves. So we are now the libevent maintainers. Libevent is a high-performance, socket-based or pole-based or now buffer event-based approach to handling a whole lot of network events at once. We patched OpenSSL to use less memory when you have a lot of different TLS connections going at once. And we have a Tor firewall helper lib that we're trying to let, if you're running a Tor bridge or a Tor relay at home and your router supports UPnP or PMP, then there should be an automatic way for your Tor relay to say, hey, NAT, can I please pierce through you, and you can port forward to me. So there are a pair of libraries, libnat PNP and mini UPnP, that could sure use some help in terms of keeping them up to date and maintained and secure and so on. Yeah. And we'd love to have that working better.
And we also wrote Tor Firewall Helper to be rather extensive in the sense that we hope that other people would say, hey, there are these other ways to punch through a NAT, and then run this, and we have it running from Tor. And so in theory, we could extend it to do some of the really cool ICMP tricks to be able to open up bidirectional connections through a NAT that have nothing to do with these weird router protocols, but rather use TCP tricks. So if you have ideas for bypassing NAT, which require a client or another client, this could be a place to plug it in, and we would love to hear about how that could happen. Or if you just have another program that interfaces with common routers, like the community Linksys routers or something, for automatically mapping ports, that would also be a really interesting way to extend it.
Okay, so that was talking about OS images and various things where we try to get Tor bundled on various places. Now let's look at the metric side of things. So we have a bunch of different sort of web services that you can go to and learn about what's going on the Tor network. The one I'm going to talk about first is Compass. It started out as an idea of let's get a sense of diversity and performance of the Tor network. How many different relays do we have? What sort of locations are they on? Are there bottlenecks in certain different places. So you can go to compass.torproject.org and you can say, give me a list of the exits, give me the list of the fast exits, group by country, stuff like that. So here's a list from a few weeks ago of the fast exits in the network. And we've got Torland running on some sketchy cheapo provider. And under that, we've got a pair of CCC exit relays, and then we've got a Tor servers relay. And you can see what the fraction, what the chance of exiting or the chance of being picked as a guard or a middle hop is for each of these relays. And these are the top ones, but that top one is 6.5% of the time when you use Tor, you exit from that relay. So that gives you a sense of the diversity we've got going on. We've got 3,000 relays in the Tor network, but the top 50 or so are something like 70% of the network by capacity. So there's a lot of balancing to be done between performance and anonymity. So looking at it from another direction, in terms of group by country, at this point when I took this snapshot, 31% of the exits came out of Germany, and 22% of the exits came out of the US. So part of the challenge there, I mean, it's great that we've got lots of people in Germany running exits, we need more, but we also need to understand what the diversity trade-offs are with respect to how many exits we have in different places. And to see that even more clearly, grouping by AS, there's a single AS in Germany, RR-bone, that the CCC has like a twin bonded gigabit connection to, and they run 4 very fast exits, and the chance of coming out of that AS is 19%. So 1 out of 5 times you exit from Tor, you're popping out of that same location in Germany. So that's good for performance, it's good for handling the 500,000 users we have every day, but it would be even better to have more diversity. And this gives us a way to visualize what we're getting out of that. The second AS down is 11% and then 5 and so on. So that brings us to Atlas, which is another way of visualizing the data that we've got. Here's a look at the bandwidth handled by one of those CCC relays. So at this point, back in March, it was using 10 megabytes a second, and then it bursts up to 30 megabytes a second in each direction on average. So this thing is pushing 250 megabits. This is one exit relay that's pushing 250 megabits. So it's great that we're able to scale to handle that. It's great that we have all this load on the network that wants to be able to use this. It's great that people are running these relays. Boy, do we need more, because at this point we have 20 or 30 really fast relays, and we'd love to have some more.
Thank you, by the way, for the people that run these relays. Seriously, this is amazing. Can you imagine that? There's somebody pushing 35 megabytes a second on this relay. That's really great. That's what makes the Tor network possible. So to all the people that are running relays or thinking about it, this is a huge difference. This is like ridiculous numbers of connections. I mean, it's many, many megabytes of traffic per second, right? Of people who you are actually helping. It's pretty fantastic.
And the last way, yep. So another way of visualizing this is looking over time at the probability that this node would be picked for the green as the third hop, the red as the first hop. And you'll see that there are some points where it gets up to something like 8 or 9% of the time you're exiting from this relay. So this hopefully will give us a better sense of what the diversity is we're looking at. And part of our challenge from the research side, and we'd love to have some help here, is what's the balance between if we start cutting off the really small relays, do we harm our diversity much? Not really. Do we improve our performance because the chance of picking a really slow relay goes away? On the top end, maybe we should be using these fast relays less so that we improve our anonymity, but then we're not making use of the capacity that's being volunteered, so there are a lot of trade-offs that we'll have to do in a different talk. And we also have the 18C3 symbol up there, because Atlas could use a lot of help if you're a big fan of Ajax or other approaches to making JavaScript work like this. We would love to have some people working on visualizing our data better. How many people here are excited about that topic? I see one hand. So we'd love to chat with you afterwards.
Yeah, we definitely would love to have people who do not just data visualization, but generally graphic design that can help us to visualize anonymity in general. It turns out that's a really hard problem. Surprising, right?
So metrics.torproject.org has a whole lot of graphs of historic network data and performance and so on. So this is a graph. The green is the capacity of the Tor network over the past couple of years. So you can see that it starts down at the 750 megabytes per second on average, and then it goes up to 3,500 megabytes per second. So we've grown 6-ish fold in the past couple of years, which is great because the number of users has also grown and the performance of the network has gotten quite a bit better. We'll see the Tor perf graph in a bit. But this shows the purple line is the actual load on the network over time, which shows as we add more capacity, more people show up to fill that capacity. So from my perspective, there are an infinite number of people who want to use Tor in the world. And our challenge is to provide a network that can handle as many of them as possible. And the more we've got, the more diversity we have, the safer they all can be. And then another piece of the metrics portal is relay search. You can show up and for example, if you're running a relay, now you can learn about what it looks like in the consensus and when it last published and stuff like that. Another nice feature is called the exonerator. The idea is it has a big historical database about every IP address and port that was a Tor relay over time. And if you saw a connection from somewhere and you want to know, was that Tor back in January 1 of 2011, then you can look it up on here and it will go through the consensus documents and say, yes, I found a relay with that IP address, and yes, here's the timestamp.
So this is, I think, maybe one of the more interesting things that people can do to help, in the sense that if you don't want to write code, if you happen to have a relationship with law enforcement, this is a really useful tool that telling them about, so that when they wish to raid someone's house, for example, they can look here and decide, oh, they're either running Windows or they were a Tor relay. Maybe we shouldn't kick down their door. And making sure that that is part of the process that people go through is an educational issue, especially for law enforcement. But in general, it is a useful thing to be able to look at that. So teaching people about exonerator may actually really make a big impact for certain people. And it may also be the case that when they don't check it, it is possible that we can ask them why they didn't check it. Did they not know about it? And if, for example, they check it and they still do some heavy-handed thuggery, such that there's a really big problem where they seize a lot of things, we can say, why did you do that when you knew that it was a Tor relay? And that changes the dialogue a lot, because it allows us as a community to respond and to do it in a responsible way that is easy to use. And for example, there are people who have the entire database and they don't query us, they query the database directly. And they use this, maybe you could talk about that, but some groups use this to be able to know, without being heavy-handed thugs, that that's what's going on, that it was a Tor exit node or something else.
Yeah, we're making a lot of progress at teaching US law enforcement about what Tor is and why it's useful for the world, to the point that a lot of them actually use it to be safe on the internet, both at work and at home. So part of our goals are to teach everybody in the world, including law enforcement, how things like Tor work. And I actually met with a bunch of detectives in Stuttgart a couple of years ago, where we talked about how they wanted something like this. So then we started publishing all the historical network data, and we gave them a tool like this, and they can pull down the database and query it privately. I mean, I don't want to know every IP address that the Stuttgart detectives are thinking about kicking the door down for. So I'm happy that they're able to do that in a private sort of way. And part of what we want to do is teach people who are, I mean, first of all, we need to teach the policy side of people so that they stop making stupid laws. But we also need to teach the people who actually kick down doors, first, before you're going to waste your time going out at 5 a.m., there's this database you can query, and it can tell you whether it's going to be a dead end or not. So one of the ways that an FBI person explained it to me was, look, I have this case. I've got 12 leads, I've got 12 things that I want to investigate, and there are 36 hours before this doesn't matter anymore. Tell me which ones aren't going to work out for me, and I can do my job better, and also I don't hassle your relay operators. So there are a lot of ways of balancing this that I think can improve both sides.
That's also, I guess, maybe worth mentioning is that you really should run an exit relay. So we're running.
Yep. Okay, so we've got some other tools in the metrics database. Consensus Health gives you a sense of which directory authorities voted in what way for which relays, so we can start debugging things when votes go wrong. We also have torperf, which is a set of scripts that pulls down 50 kilobyte and 1 megabyte and 5 megabyte files over time. And it gives you a graph of the average latency over time of how long it's taken to do this. And this gives us a sense of performance over time. We have another 18c3 logo up there because we'd really love to have some help on the torperf side of things, in terms of automating it, in terms of visualizing things more, in terms of testing realistic web pages. Right now, we fetch a 1 megabyte thing, and we say that's sort of like a web page. Actually, web pages involve round trips and images and so on, so that we're not actually accurately assessing the performance that a normal user would get from Tor. We also have a tool called Tor Weather, where you can sign up and say, when this relay goes offline, can you send me email? And that's very helpful for people who don't want to set up Nagios on their own, and they can learn when their Tor needs a kick or an upgrade, or when they've run it for 2 months and now we'd like to send them a t-shirt if only they ask for it, that sort of thing. And then there are a bunch of back-end scripts. Mostly OnionU and PyOnionU are the database back-ends that let you handle all of this data. We've got tens of gigabytes of network data at this point, and we'd love to have some help on the database side, managing that, making it fast to query, that sort of thing. Okay, now we're going to turn to an entirely separate topic, censorship resistance, pluggable transport, stuff like that. So there's a tool called Obfus Proxy, which is a transport for Tor. So there are a bunch of adversaries out there, we talked about them last year, who do DPI to look for the Tor protocol and say, you're doing a TLS handshake with the following properties, I'm going to cut that connection. So Obfus Proxy has a variety of ways of adding a layer of encryption or obfuscation to the traffic flow, so that you've got a little shim on the Tor client side and a little shim on the bridge side, and then you can transform the traffic going across it. And we've got the main one, Obfus Proxy, is in C, and we're working on a Python version as well, so you can choose whichever one you'd like more. Flash Proxy is another approach here. So the idea is you basically put this little badge on your website, and then anybody who shows up to your website is given this AJAX script, which turns them into a Tor bridge. So it turns their Firefox browser into a volunteer, bridging.
David, are you in the audience right now? No, maybe not. But unfortunately, but well, it was a full room.
It's written by a grad student at Stanford named David Fiffield, who is also an Nmap developer and a Tor developer. Great guy. We'd love to have some help working on Flash Proxy to make it work. It's a full-fledged anti-censorship scheme. Part of the challenge right now, so the volunteer goes to the website and fetches the AJAX thing, and it turns them into a Flash bridge. It used to be called Flash because we used Adobe Flash. Now we use AJAX, and you should think of Flash as in real quick rather than horrible, badly written binary blob. And so one of the challenges is the AJAX is able to make outgoing connections, but it can't receive incoming connections. So the normal bridge model for Tor is you listen on a port, and the censored guy learns about your address and connects. The new model in the Flash Proxy approach is the Flash Proxy connects to the Tor network, and it learns about the censored guy, and it connects to him. That works great, except the people in China are behind 16 nats. So there's no way that you're going to be able to punch through to them. We need some sort of firewall NAT piercing thing. So I hear that WebRTC, basically the Google Voice people are trying to add Skype-like properties into Chrome and Firefox. They want NAT piercing also. It would be great if we can leverage that into being able to do NAT piercing so that we can have fully bidirectional bridges inside your browser. All you have to do is go to the web page, set it up, leave your browser there. You're a volunteer.
Who actually here has a website, that you run where you can just put stuff on it? So it would be really interesting if you told us how long it took you to set that up and just add it to your website and see how it works. Because we would love it if a whole bunch of people did that, especially with popular websites, and let us know what the experience was like for you to set it up, whether or not it's a pain or whatever. So we can improve it, and so that we can see it work, and we can have a lot of diversity. Yeah, we have 5 minutes.
Sorry. If you have a question, walk to the microphone and speak into it.
5 minutes.
And by the way, I think it's time for Q&A now. If you have questions, don't introduce yourself, just ask a question, otherwise we'll cut you short.
Just to this project, just to this to Flash Proxy, I really love the idea. Is there a way to implement this on a WordPress blog?
Yes.
Yes, you just add the badge and it's all set. It's just HTML that you hand to the user when they show up.
I mean, in theory, you could probably talk to Matt Mullenweg at WordPress and say, hey, would you put this on every WordPress blog?
Okay, so we're going to zip through the last couple of these things, and then we'll hit some questions, and then we'll be around for the rest of the Congress to answer them. You want QA right now?
If you want to have a Q&A, you must have it right now.
Okay,
I can give you a maximum of about 10 minutes, and then you have to really cut you short.
Let's zip through the last few slides to give you a sense of what else there is, and then we'll have a few questions. So BridgeDB is a service, it's a web service and also an email service. The idea is that it gives out bridge addresses in a way that the bad guys can't learn all of them, but the good guys can learn some of them. We added reCAPTCHA support. We've got IPv6 bridges, which no country on Earth censors at this point. We've got obfusc proxy bridges, but not enough. I'd love to have some more people running them. There's another really cool tool called BridgeGuard. So the idea is, right now China looks for the TLS handshake that happens between the client and the bridge. And when it sees a certain set of ciphers, it does a follow-up active probe, talks Tor to it, and if it talks Tor back, it censors that bridge. So China is actually actively scanning the internet for our bridges. BridgeGuard is a little IP tables rule that you run just on the bridge side, and when it receives a connection, it lowers the MSS, the maximum segment size, so that when the client sends its list of ciphers that it supports, it gets broken into 2 packets, and China never sees it. So that's the red line. And this works beautifully right now, but that is one trick of many. We would love to have some help. We put the star up there. We'd love to have some help, people looking at other ways to fragment and basically mess up various DPI boxes.
One real quick thing. Also, with this BridgeDB thing, with reCAPTCHA, it means that when sensors are trying to extract information from the BridgeDB, they're helping people to be able to read when they are failing, and even when they're being successful. So no matter what, we get to use their labor to benefit humanity. And in this case, this is just one of many, many, many cases where we can do something really smart like this. So if you're really good with network protocols, this is just one trick. We'd love to hear about more. This is, sorry. This is an entire talk in itself. The Open Observatory of Network Interference is our project to try to make sure that we have the right to observe. So that is, we have peer-reviewed methods, we hope, we would like your peer review, of finding censorship and surveillance on the internet. I recently ran this in Burma, for example, and I was able to overload their filter. It was too efficient, and not as efficient as I guess it could be. And we were able to detect, in fact, that there was censorship based on the fact that the Blue Coat device crashed. So even without knowing what the censorship was in terms of which sites were blocked, we were able to find it. It's meant so when you want to write a test for censorship detection or surveillance detection, that you can just add it to the framework that already exists. It's free software. All the data will be open and freely available for people. And the idea is that we can then have metrics and visualizations that use this.
Okay, so there's another tool called Tor2Web, and the goal there
Sorry,
is...
it's a big community, man.
Yep,
I mean, we want to give credit where it's due. There are amazing people working.
You're already out of time.
Yeah, all right, great.
So there's another tool called Tor2Web, and the idea is if you want to visit a .onion address, a hidden service, without having any Tor client installed on your side so that the rest of the world can read these things, then Tor2Web is basically a gateway to allow that to happen. So part of the challenge is how do we provide scalability? How do we, in the usability side, how do we let people access through the gateway without screwing up the security side of it?
If you have questions, now's a great time to culture jam this and get in line.
Yep, that's true.
Please get up and quick before he says anything else.
Sorry to interrupt you. I'm directing the questions. Since there are lots of questions and the people on the internet have less of a chance to start asking questions, the first 2 questions will be for the Signal Angel to ask. And afterwards, then the questions from the room there will be room for that.
We should make
Again,
Tor mail.
don't introduce yourself, ask your question briefly, and we can handle as many questions as are left in the last 5 minutes.
And while people are lining up, I wanted to very quickly mention this. Who here uses...
Okay, Signal Angel, go ahead.
So, who here uses Tor mail? Because after I've given some Tor talks, people...
I would really like to pose a question now, sorry.
Yeah, go for it, you're not talking.
I mean, the Herald told me to ask a question, so I do that. And it's probably the question.
Right, it's in the
It was asked by many people. So the Tor project was initially founded by the Navy and supported by ONR and DARPA. And as of this year, it's still 80% funded by United States government, including CIA front organizations, okay. But this fact is well documented. It's even on the Wikipedia page about Tor. So the big question is, why should we put our trust into this project? And why do they give you that much money if...
Okay, Signal Angel, you have to be short too.
Yeah,
I think the question is clear now.
I think you get the question.
Well, so there are two parts. I'll let Roger talk about the historical part, and I'll address the second part. Why should you trust anything is the first question that immediately comes to mind. And the answer is you probably shouldn't, unless you can verify its source code, you can be a part of the network, you can be a part of actually understanding how the system works, unless you actually have some idea about those things. So what system exists right now out there where those things are true, other than Tor? I don't really know of any other alternatives. That seems to me like that is a useful metric for looking at it. And secondarily, have you looked? Have you found problems? Are you part of the network? If you're part of the network, part of the design is that even if some of the worst motherfuckers on the planet are running Tor relays, you're still keeping people safe, and you yourself can be safe. Now, as far as the historical part, I'm sure Roger has a lot to say about it.
Yeah, so we started out, I got research funding from the Naval Research Lab to work on them for research papers, and then one of their funders wanted a demo, so I whipped together this thing called Tor, and we demoed it. They didn't write any of the code. I wrote the code. From there, we added Nick Mathewson, another developer. So, I mean, from that perspective, we wrote Tor. Where the money came from, you can see what it did. We've written Tor. It's open source. It's transparent. We've got a big pile of research papers here that we'd love to have some help with people looking at. There's basically 200 or 300 anonymity, anonymous communications, anonymous publication research papers that are out there. The whole system is transparent. We have a huge community of people finding and fixing bugs. We would not have that community if we had no funding. I'm pleased to have whatever funding we've got, and we show everybody everything we do. So you don't have to look at the Wikipedia page to find out where our funding comes from. We publish our financial documents that explain exactly where the money comes from and what we spend it on. We try to be as open as we can.
Okay.
Okay, final question from the Signal Angel, and keep it brief, please. And we may have a chance for one question from the room, but...
Okay, when there's no question about the room, then I'll go on with the next question. So how do you, it's probably related, so how does the team prevent other people that become part of the community contribute malicious code, like when there are sock puppets of some agency or something? So if other interest groups...
Okay, the question is, how do you prevent insertion of malicious code? And you have 1 minute left to answer that question. Thank you.
You want to take it?
Peer review is the answer.
Okay, and with that much projects, you have the community is large enough to provide that?
Well, no, obviously we need help with it. That's what this whole talk is about. But we try our best to make sure that code that is checked in has been reviewed by people. We try to make sure that we have an open and transparent process. We try to make sure that people are leading projects. Even if they're not always able to do everything on the project, they're at least somehow aware of it. And that's why on the volunteer page, which is, of course,
okay,
here.
Time is up.
Totally. But we try to make
Time
sure.
is up.
We try to make sure.
Thank you so much.
And we could use your help.
Thank you.